Hi, this is an introduction to logic. I'm Mark Thorsby, and this course overviews the basics of categorical, propositional, and predicate logic. Today we're taking a look at categorical logic, and we'll be discussing the traditional square of opposition and how to use the traditional square of opposition um, to test immediate inferences. It'll become important, especially later on when we look at categorical syllogisms. So anyway, for those of you who've been watching, welcome back. I want to start off with a quick review today. And what I want to review is something we haven't discussed in a couple sessions here, and that is the existential fallacy. Um, and, and the reason I want to discuss this is because we're talking about the traditional square of opposition. We looked at the modern square of opposition originally. Some of you may be wondering, why are we looking at the traditional one after the modern one? And it goes back to the idea because the traditional square of opposition actually allows you more options, whereas the modern square of opposition is much more sort of minimal. Okay, and it goes back to the difference between Aristotle and Boole, right? And basically, to keep it simple, the debate these two philosophers have, separated over a couple millennia here, is on the question of whether or not universal statements, whether or not universal statements make claims of existence. Do universals claim existence? Okay. Whereas Aristotle thought yes, they do, and Boole thought no, they don't. Okay. So let me give you an example. Remember, we're talking about in categorical logic, are the universal claims we're looking at are the A and the E claims, right? All S or P and no S or P. Aristotle thought, for instance, that it goes back to his epistemology. And for those of you who are unfamiliar with that term, epistemology means your theory of knowledge. And his theory of knowledge was that you observe particulars, right? You have all these particular experiences, but that over time you do learn things universally. For instance, you learn universally that all plants need water, right? So you can make an A statement, all plants are things that require water. And Aristotle thought that through your experience, you really could come to know things that were universally true. Whereas Boole, as a modern philosopher, he steps back and says, well, wait a second, do you really know that? Because in order to know that with absolute verifiability, you would actually have to be able to inspect, in our case, plants, right? All plants are things that need water. You'd have to visually or in some way inspect all plants in the entire universe to know whether or not that claim is true. That, of course, is impossible. Because it's impossible, Boole said when you make a universal statement, it does not include within it a claim of existence. So he said no. Whereas, for instance, Aristotle said yes. Now, why does this matter for us? It actually matters hugely, right? Because remember, go back to the traditional square of opposition. If we put our A here, our E here, our I and our O statements, right? The modern square of opposition was that the E and the I are contradictory and the A and the O, right? But wait a second. Let's go back to our example. What if I make the A statement, all plants, right, are things that need water, right? Doesn't that mean that some plants are things that need water, right? Because if all plants are things that need water, it would mean that at least one plant or some plants also are things that need water. Um, so you can see here that in the modern square of opposition, we basically just struck out and described what the diagonal relations are, right? But the question here is, well, what about the vertical and the horizontal relationships? Is there a way of knowing exactly what the truth values are here, right? So if A is true, will I be true? This is a sort of question. Because it would seem that if all plants are things that need water, some plants are things that need water. Now, because of the existential fallacy, Boole says that if this is true, that means you don't know that this is true. Okay? In fact, So he said that strictly speaking, you can't know what the vertical and as well what the horizontal relationships are. These are strictly speaking, um, logically undetermined relations. Okay, so that was the modern square of opposition. And again, the difference here goes back to the existential fallacy in the sort of epistemological debate those two philosophers have. So we're talking about the traditional square of opposition, and so we're going to be taking on Aristotle, or at least you might say the classic view of the square of opposition. And what we're going to see is that we have actually that there are horizontal relationships between these as well as vertical relationships. Okay, now again, let me just go over this one, the contradictory. Remember, a contradictory claim means that if A is true, O has to be false. They can't both, they have to always have the opposite truth value. If I is true, E has to be false, and so on and so forth. Okay, because remember, contradictions are strictly speaking, it's like the mortal sin in philosophy or in logic. A contradiction is to say that something both is and is not at the same time, in the same place, in the same respect. And in fact, today you might talk to a modern philosopher, and they would tell you something about the law of non-contradiction. So it's really actually a critical function. And if you want to learn more about this, take a look at our video on the modern square of opposition, or at least go back and review that. What are we going to talk about here? Let me go through and explain what these different relationships are. Right? Let's start with the subaltern, actually. Now, basically, we say the vertical relationships are what we call subalternation. And subalternation works like this. And the thing to remember here is that truth flows down and falsity flows upward, right? So let me maybe change the color of this pen. So if the A claim is true, that means that the I claim must be true, okay? But what happens if the A claim is false? The answer is, I don't know what the I claim would be, okay? So in subalternation, if the top is true, then the bottom will also be true. And simultaneously, it also means that if truth flows downward, falsity flows upward. And I'm not going to go through and explain why that's the case in this video, because really what you need to do here is just learn the mechanics of using the square of opposition. So that means that if an I claim is false, then an A claim must also be false. Okay? So let me erase this here and I'll give you an example. Right? So if an I claim is false, then an A claim has to be false. But if an I claim is true, what about the A? Answer is it would be unknown. Okay? So you have to be very, very strict here. So we'll just put here, for subalternation, truth flows downward. Right? Falsity flows upward. And for some reason in my mind, and this may help some of you may object to this, but I tend to think of this theologically, right? Like sort of God, truth comes from God, so truth flows downward, and humans are sinful or something like this. And I don't know if you really believe that sort of theological thing, but it sort of helps me to remember it on my own. Truth flows down, falsity flows upward, okay? Um, and that's the same with the A and the I as well as the E and the O. Subalternation is the same on both sides. And you're going to find that subalternation is pretty easy to get a handle on. Now, what about the contrary relationship? The contrary relation. The contrary relation means that at least one is false. At least one is false. They're not both true. Right? Let me write that. They're not both true. Okay? That's really important. Right? So at least one is false, they're not both true. But it does mean that they could both be false. They could both be false, okay? That's an important distinction. Now, you're going to see that subcontrary is precisely the opposite. And this is why it's somewhat confusing. It'll take you, eventually you're going to have to memorize this, but it'll take you some time to get used to it. But once you do, it's not too bad, right? So for subcontrary, at least one is true. right? But they're not both false, okay? They're not both false. Now, what's interesting here is that they're not both false, but it's possible for them both to be true, okay? But these are the basic rules, okay? And you're really just going to have to commit them to memory, okay? So the contrary means that at least one is false, right? So let me go back here. Let's input some values and see what we can get here, right? Let's say that, um, well, all we know is that A is true. If we know A is true, can we compute the values, right? Now, the thing to remember is usually when you're trying to compute the values on the claims is if the A statement is true, then the contradictory, always start with the contradictory, then you'll know that this is false, right? If this is false, right, and falsity goes upward, then you know E is false as well. If E is false, then you know I is what? It's true, and of course C, it matches the rule, truth it goes downward, okay? So that's an example here. But you can see here, I started with the contrary and then used the subaltern. I could have rather just started with the contrary, because if I said this is true, at least one of them's false, then that means that this one would have to be false. And simultaneously, or let's go back here and let's start over here. And let me give you another example. Let's re-input the values and sort of compute the truth values. And that's really what the square of opposition is. It's a way to compute truth values. So let's imagine, for instance, that an O statement is true. What can I determine? Now, I always say start with the contradictory, but let's stop there. Let's just sort of start by thinking about the subcontrary. Well, at least one of them is true. They're not both false, right? Okay, well, if at least one is true, I know this one is true, but they still could both be true. Okay, so that means now let's jump here to the contradictory. If this is true, then this has to be false. Okay, this has to be false. Now, if this is false, remember, falsity doesn't go downward, so I still don't know the value of this, okay? And the subcontrary doesn't tell me, so the question is, can I figure out what this value is here? Okay, well, remember, what's the rule for the contrary? At least one is false. Well, here's the one that's false. They're not both true. They're not both true. Which means, but they could both be false. So you can see here, actually, if I just started with T, then all I can compute is the contradictory value. These remain, for me, unknown. Okay? So you can see here the traditional square of opposition, though it gives you much greater flexibility than the modern square of opposition in terms of computing truth values, it's not foolproof. You can't necessarily know everything. Okay? So what's going to get interesting in your homework is you're going to be given exercises that then you have to use the square of opposition to determine their truth values. Okay, so maybe let's do a couple of those, and I'm going to pull them right from the textbook so you can see them. Right? Okay, let's start with this one. All Swiss watches are true works of art. In fact, let me snip this. Right? And this is, again, we're not doing full arguments. Eventually we'll be doing full arguments. All we're doing right now are taking a look at, let's see here. Let me see if I can move this over here a little bit. Okay. All right, so that way we can see it. I hope it's not too small on your screen here. Okay. Um, I'll I'll just go like this. I think that's probably the best way to look at it. Okay. Okay, so let's look over here at this statement. All Swiss watches are true works of art. What you need to do, the steps here, first thing you need to do when you get an ordinary argument, inference argument here, is you need to first determine the type of statement. Okay, now all Swiss watches, I automatically know that this is an A statement. And notice it's saying, therefore, it is false that no Swiss watches are true works of art. So this here, no Swiss watches are true works of art, this is an E statement, right? And they're saying that this is false. this claim is false. Well, let's start off with this. Remember, when you test immediate inference, you're going to assume that the premise is true. So let's go back over here. If the A statement is true, right, what about the E statement? Well, at least one of them is false. So by the rule of contrary, this has to be false. That works, right? And here, of course, we could compute it. Truth flows downward. If this is true, this has to be false. So by the rule of contrary, or if you went through subalternation contradictory, this would be true. So this turns out to be a valid inference, okay? So that's how you can use, in a little more concrete fashion, how you can use the square of opposition to test an immediate inference. Let's do another one here. Let me erase the inputs that I put in there, right? Just erase that. Okay, let's do one more here from the book. Let's go new. Hold on, maybe. Sorry. Okay, here's another example. And these are in your book, so, and I like using these examples that he gives you because it gives you a way to actually sort of evaluate it. And you can read his explanation too if I'm going too quickly for you. Oh, that didn't work, did it? No. Okay, let's try that one more time. Okay, so here's another example that we can use to test the square of opposition. Okay. Okay, so the first step, I didn't finish writing the steps in the last one, so I should mention that. The first step, of course, is to determine what types of statements they are. Next, determine what the truth values are being claimed in the inference. And then the third step is to go over to the square of opposition and run it through, compute it, run it through the sort of the algorithm of the square of opposition to figure out what you can know. Now, in some cases, it's good to mention if you end up with a conclusion that's logically undetermined, that it's invalid. I should mention that. Okay, so let's run through this one. Some viruses are structures that attack T cells, okay? That is what kind of statement? It's an I statement, okay? So they're starting with an I statement and they're concluding with some viruses are not structures that attack T cells, I think it must say there. They're ending with an O statement. Now, since we're going to assume, if it doesn't say anything, we're going to assume that they're thinking that the I is true and therefore that the O is true. So let's look here at the square of opposition. Can we figure it out? Okay. So we started with an I statement. We said that the I is true, right? And what we want to know is what the O is. What is the O statement? Well, let's run it through. What can we know? Well, we know that truth only flows downward by subalternation. So subalternation, we can't do anything with the A over here. So that's sort of problematic. We do look, next thing is to look at contradictory, right? If this is true, E has to be what? It has to be false. Okay, but again, subaltern, falsity only flows upwards, so you can't do anything with the falsity up here. Okay, well, wait a second. What about the subcontrary? Remember, the subcontrary rule says that at least one is true, but they're not both false. But they could both be true. So if at least one is true, this one we know is true, but I can't infer any more than that, okay? My last hope is to look at the contrary rule and to see if I can figure what that is, right? So this says at least one of them is false. They're not both true. So this is false, but they could both be false too, right? Which means that my contrary rule doesn't give me any further mileage to answer it. So the A in the E values are actually undetermined. They're logically undetermined. So if we go back over here and say some viruses are structures that attack T cells, therefore some viruses are not structures that attack T cells, this is actually an invalid inference. This is invalid. Why? It's invalid because it's logically undeterminable from the square of opposition at this point, okay? So this is an invalid inference, okay? So you can see here how the square of opposition can really give me a good handle on assessing these sort of immediate inferences and eventually arguments in the fuller sense. Because think about it for a moment. If someone actually, imagine for instance I was at a university lecture and I heard a professor say this, right? Imagine I'm, taking a biochemistry class, and the professor, I don't really know anything about the subject, and the professor says some viruses are structures that attack T cells. Thus, some of the viruses are not structures that attack T cells. When I just hear that, it sounds logical, right? But you can see here, now that we've actually evaluated, it's actually not logical at all, right? It could actually be true, right? And in fact, we might say that it probably is true because it seems likely that some viruses aren't. But this claim here does not count as evidence for this claim, okay? It's insufficient, right? So I hope you can at least get a sense here of the powerful tool that we're slowly developing here in this logic course, because slowly, and maybe it's sort of interesting, is that when you hear these sorts of things in ordinary language and conversations, think for instance cable news, when you hear people debating and making arguments on cable news about stuff. Um, you can see there might be a lot of different arguments where people give evidence, but the evidence they give isn't sufficient to conclude whatever it is they're claiming. All right, so it's sort of actually a powerful tool. One thing I always tell my students is that the better you get at logic, or at least the way you know you're doing better in logic or you're becoming logical, is by how many friends you start to lose. Because no one, because many people think illogically, and let's see, where did I go? Many people think illogically, and no one likes to get called out on it. But the better you get at logic, the more you'll see that actually probably a vast majority of the arguments you hear in ordinary life are actually illogical. Okay. Now, what I want to do is what happens if people make claims like that? Let's talk about fallacies, for instance. Okay. The first fallacy when people make wrong moves, we can say they make illicit. Well, here, let me just list off some of these fallacies. There's an illicit contrary fallacy. There's an illicit subcontrary. And there's an illicit subalternation. Right now, what fallacy was made with this argument? Some viruses are structures that attack C cells, therefore some viruses are not structures that attack C cells. This was an I statement and it went to an O. Now, what you have to do is, if by looking at the square of opposition, you'll look to what is the quickest way relationship between the two. This person went from an I to an O. And that, since that value was undetermined, we call that an illicit subcontrary. Okay, so what you want to do when you're trying to figure out what fallacy is committed in the immediate inference, look to the quickest move that people make between the things. Notice we don't have an illicit contradictory fallacy. We don't do it because to commit a contradiction is by definition, it's the very core of what any fallacy does. So um, contradiction is a fallacy automatically, if you will. Okay, so so when people make truth claims illicitly, right? Those are fallacies. So if you made if let's say I made an F statement and went to an E statement, I said it's false that no monkeys like bananas. Therefore, it's true that all monkeys like bananas, right? That actually, even though that sounds logical, maybe it's not. It actually commits the illicit contrary fallacy. Okay. So let's go back down here. So these are the sorts of fallacies, and what you're going to see is the homework is going to ask you to find these. Now, you'll see that with this textbook, we're actually building our fallacies here. We have more fallacies. These are just the 3 fallacies we've learned today. The other fallacies we've learned, of course, is the existential fallacy. And remember, there's 2 types of existential fallacies, right? There's the existential fallacy from Aristotle's perspective, and there's the existential fallacy from Boole's perspective, right? Where for Boole, any claim that begins with the universal and goes to claiming something is true in a particular, this always commits an existential fallacy. And of course, and of course, if you talk about things that don't exist, if you make arguments about unicorns and wizards and stuff, that also commits the existential fallacy. Whereas for Aristotle, universals are acceptable. Now, what we're going to see is because there's sort of a debate here between Boole and Aristotle, arguments that pass the test for Aristotle but not Boole are known as conditionally valid. Right. Conditional, they have conditional validity, whereas arguments that pass Boole's existential fallacy test, these are known as unconditional validity or unconditionally valid. Okay, and so that's an important distinction. Why? Because for Boole, since he has the stricter test, any argument that passes Boole's test is going to be a valid, period. Because whatever is valid for Boole is also valid for Aristotle. Whereas for Aristotle, if it's valid, if it's a universal to a particular claim, then that means that it's conditionally valid, conditioned upon whether or not the universal claim is true. And of course, you can hear Boole in the background saying, but you can never know that. There's the existential fallacy. The other fallacies we've looked at here, if you remember, this is from our last time. There's the illicit, let's see, what was it? From 4x4. The illicit conversion. Remember we talked about conversion, aversion, and contraposition. There's the illicit conversion. And number 6, there's the illicit contraposition. Since since aversion is valid for all statements, there is no fallacy there. So now the reason I'm mentioning these things, even though our chapter isn't really about them, is because your homework is building on them. And so if you see these, and one of the things your book is going to have you do is going to be using these logical operations of conversion, aversion, and contraposition. For instance, let me sort of give you a quick tour of what the homework looks like. Sorry, and I, of course, read this, right? So they're going to say, for instance, use the traditional square of opposition to find the answers to these problems. When a statement is given false, simply enter an F into the square of opposition and compute, if possible, the other truth values, right? And you can see here, they want you to do this first claim, then they have all of the different ones, too. So the first set of homework is pretty easy. It's just doing those computational values. And then here they're also going to say, use the traditional square of opposition to determine whether the following immediate inferences are valid or invalid. Now, one of the things I want you to watch for in this homework is that occasionally, I believe, they're going to do an aversion or a conversion in here. And so if you see that, they may be mixed in and laced throughout the homework. So keep on your game here and make sure to see if they're doing also any of those logical operations that we looked at before. Okay, so that essentially, and so here they're also going to talk about the distinction between validity, invalidity, soundness, and unsoundness. And there's discussion about the existential fallacy. You can see here there's also this where there's an operation, was the new statement, what's the truth value. You can see they're doing subalternation, but here's an aversion. Remember what the aversion was? I hope so. But anyway, that's what the homework is for this week. Okay, thank you very much for watching. I look forward to seeing you online. On our next session, we will be talking about Venn diagrams from Aristotle's perspective and the traditional square of opposite from the traditional perspective. Okay, thank you very much for tuning in, and I'll talk to you later. Bye.